Hello, welcome, W.J. Burns, PHX. A subscriber to my channel asked me about these modified Philco part number 761134 local distance switch that I've produced for some of these radios that I sell, and for those of you out there that don't have one for your Philco 41/42- radios. And asked me how I produced the 3-pin adapter. Well, I'll try to keep this as short and succinct as possible. I get these cases from China. Nobody seems to produce them here in the States. And as a matter of fact, there's a few items in this item that come from China. The case is one. The micro switch is the slider is another one. So what I've done is I took the original. Let's see if I can get it here. The original Philco part, and took a measurement or an imprint of the spacing on these 3 pins and transferred them to my computer, where I have a CAD program. Then I did the layout on the pins and got a printout for a template and transferred it to, much like it's a phenolic board, transferred it to a circuit board. And this one hasn't been etched yet. And drill the holes, and the holes are sized to press fit a pin from a standard vacuum tube. This tube here is bad, so I throw them in a little bin and figure that I'll bust them up. You bust the base up till you separate the pins, and you get these 2 pins out. And then I load them in a helping hand and heat them up and pull the wire out of it, clean them up, and then I straighten the pin out in the back here where they've been flared from being set into the tube base, and then I press fit them into the holes and pin them over. See if I got one here somewhere. There. This one here has been etched, and I pin them over and solder them to the pads, and that holds them in. So once I got that done, oops, sorry about that, I drilled the holes for the micro switch, or the slider switch. And this here is just hand drawn, and then it's etched. And I will show you how I proceed to build the circuit board to put it in this case. So Once I've got these circuit boards etched and the pins loaded into them, I take and I put them into the, I don't know if you can see that very well, I put them into this base piece and centered them up pretty well in there so that they'll fit pretty well. And then I take a weight and hit the back, putting an imprint into the plastic where I can see them and get them marked, and I drill the holes for the pins to slide into the base. And now once I got that done, I take and I load this up in my helping hand. Let's see if I can get this in a better position for you to see. I load it up in my helping hand and I start populating the board. Now these micro switches will fit into these holes, and you want them just barely to stick through. They will go on this side, and they will barely stick through the back side of the board. And then I flex them. Hope you have better hands than I do. I flex them slightly over so that I can get a soldering iron in there and solder them in. You don't want them to stick through too far through, or else this front part of the switch will set back too far from the face once you have this top snapped on. That's what I do with that. I get that soldered in there first, and then I got it back in my helping hand, and I take the parts needed for this thing to work. The resistor is a 1/4 watt resistor. It is a 3.3 kilo ohm resistor, and I put this on the board first, and it goes from this center part of the switch. Let's see if I can remember how I done this. To let me get something better that I can show you. Okay, here we are. This is enlarged. Here's your switch. Over here, the center lead has a 3.3K that goes to, this is actually numbered 1, 2, and 3. So, let's see where my thing is here. You hold this the same way as that. Hold this the same way as that. The center one, the resistor will go to pin 3, which is the top one. Okay, and now let me see. Let me get the switch mounted and the resistor mounted, and I'll show you how that configuration is. Okay, got the switch and the resistor mounted onto the board. This resistor is positioned in this manner to allow all the components to fit inside the case. Okay, next I take and I put in this inductor. This inductor is a 300 microhenry inductor. You can get these from Mauser. They're about a ½ inch long by about maybe 3/16 to a 1/4 inch in diameter. And I'll show you how this is going to be mounted into the board. Give me a moment to get that in. Okay, we got the inductor loaded on. Hopefully you can see this. I'm also using PTFT spaghetti tubing. See if I can get this thing to focus better. There we go. Feeling lazy today. So it goes from the center of the switch also, as does the resistor, but it goes down here to pin 2. Is it 1, 2, 3? Okay. And then the next thing is the 6 picofarad silver mica capacitor. These are available on eBay. This one here just happens to be the small version. I don't know how many versions they have. I just happened to stumble onto these, and they worked out great because they're small enough that they don't take up much room. And let me get this mounted, and I'll show you how that one is done. Okay, here's the, let's see if I can get this lazy thing to focus. Okay, there's the 6 picofarad silver mica cap mounted. It also comes from the center leg of the switch and goes to pin 1. Okay, now the last item on the board is a 0.01 microfarad capacitor, and it will fit in here on the board like so. And I'll get that mounted, and I'll show you how it's done. Okay, pretty much all set on the circuit board. The 0.01 capacitor is mounted in. can see everything is pretty tight in there. Now I got pretty lucky on this design in that I just went to ordering parts that I thought might be able to get something to work off of this thing. And just happened across these cases on the eBay. Unfortunately, I couldn't find anything local. I had to go across the ocean in order to get it. The switch and the case are out of China. The circuit boards, I think you can get them pretty much locally here. I'm not really sure where I got these boards, this particular boards. I got them in like a 6-inch by 4-inch form factor and cut down to fit inside this thing. So I get quite a few out of I get quite a few of these circuit boards out of the full board. Now the cap runs from one leg, in this orientation, the bottom leg of the switch, to this here will be the antenna terminal. It's what this antenna lug will solder to with a short lead of wire once it's all installed. The upper leg of the switch, there's nothing that hooks to it as far as a component. It is connected to pin 3 via a trace. So that would be the local setting, and the bottom or downward will be the distance setting. So what this is what this switch is a 2-position slider switch. I guess you would call it a 3-pole, 2-throw, double throw switch. Okay, now once that is done, I take and I bring the case up and fit this into the case to see just how it's going to fit. Make any final adjustments to it. Nestle it down in the case like so. Now you have to make sure that once the components are in and everything, that the circuit board sits all the way down flush to the case. And to ensure that, because the pins do have a little bit of a, I don't know, it's a crimping on there that will prevent you from going all the way flush. So what I've done is on the insides, I've taken a little countersink and made a little beveled inside so that it allows these things to sit more flush down. Now, once that's in the case and I am thoroughly convinced that it is okay, I take the top and I position it over the, get it back here where you can see it. Hopefully you can see that pretty well. I get that down on there in the position that it will be in when it goes to snap on. And inside there, let's see if I can get some more light on there. Inside there, where the handle of the switch contacts the face or the cap, I go in there with like an ice pick or something sharp, a needle or something, and I locate where that handle on that switch is at, the position. That gives me a point to where I can locate where to drill. I use a 1/16 inch bit to drill the hole to position the handle through the cover, and I make a slot out of it so that it allows the switch to move back and forth. Now it took a couple of attempts at it. Some were a little off and others were not even close. But after a while I got the hang of it, so to speak, and managed to start hitting them better. Now the antenna lug, where did I get those? Well, here and there, wherever I could find some of these, I've had some off of some items that I bought through Radio Shack and gutted them and pulled them out. These happened to come from a supplier of a rotor, like ham rotor. He had some lug mountings. This lug was mounted in here, and I just raped them. Took them right off of the thing and extracted them off this board, or this terminal strip. Actually, this terminal strip goes to a rotor controls where you wire them up, all your controls for your wiring, for your directional controls on your rotor, right or left, or counterclockwise or clockwise, and just pulled them out of this thing and tossed this. And I got a supply of these for my adapters, and use this as a template to mark the openings in the cover, and drilled them out, and then used the small rat tail files to shape it, and then fit the connectors into the cover. Now, once you have this mounted into the cover and the slot for your switch, you can then hook a short piece, and I mean like very short. It's only like about, I don't even think it's an inch long, piece of number 20 wire, hookup wire, solder it to that point and let it stick out, and then bring the two pieces together and solder the loose end in, and it will tie to this pad here where the cap is thing. And then you will take and work this thing so that it will close, that you can get it over the base, and then get your switch sticking through, and then snap it together. Now what I also do is to make sure that this thing does not move around in this thing, is once I got it where I like it and everything, and before I do the soldering of the cap terminal to the solder pad, copper pad, is I mash this all the way down to make sure it's completely seated, and then I take a few drops in each corner of CA glue, super glue, and give it a 24-hour period to cure, fully cure, and that will hold it in position so that it won't get loose. Because if you don't glue it down in there and to get it seated, that's why I say it's got to be seated completely to the plastic, and then super glue it down. When you go to shove it in a socket, it's going to push everything right out. So you got to make sure that that is securely done and completely cured before you put the cap on. And then once you get the cap on it and snapped it in and everything, then you can put a little double of glue if you want, or leave it undone, so in case you ever want to get into it again. So that's pretty much it, I believe. I covered everything on it. I will try to include a parts list in the description, and any other particulars about this thing. And that's all there is to it. So if you want to attempt it, good luck with it. It took me a few tries at it in order to get the thing in. Like I said, I lucked out real good on this case and the components, and managed to get all those right off the bat. It was just a matter of getting the circuit board designed and etched and finished and finalized. So if you attempt to try it, good luck on your project. I'll be around to answer any questions. Thank you for watching. Okay, there's one other thing that I need to cover, and that is when you get your project together, you want to check it to see what values you're getting on pins 2 and 3, or pins 2 to 3 on the device. And in the local setting, this is what you should be reading, or approximately what you should read on the, let's see if I can get this thing to focus in. There we go. Okay, in the local setting, you'll get approximately 11 ohms, plus or minus a few tenths, from pin 2 to 3. Put it over in the distance setting, should read approximately 3.1 ohms, plus or minus a few tenths. That's pin 2 to pin 3. In this position, you flip it up, pin 2, pin 2, pin 3, pin 1, pin 2, pin 3. So between 2 and 3, you should get these approximate readings. 11 ohms in the local position, 3.1 ohms in the distant position. And let's see if I can do this without shaking the hell out of the camera. Pin 2, pin 3. Okay, here we are. We are hooked on to pins 2 and 3, and the setting is in the local setting, and it's reading 10.5 ohms. Now we switch it down into the distance setting, and it's reading 3.26 ohms. Local setting 10.5. So you should be getting those readings on there. If you don't, well then something's amiss. I have encountered one bad inductor out of, I don't know, about 20 of them I bought. So that's all I had to include. So thank you for watching, and thank you for inquiring.